Hello and welcome to another science experiment. My name is Katrina. In the past week, Butch Wilmore and Sunny Williams have finally returned home after 9 months of being stuck in space. Originally, they were only meant to be at the International Space Station for 8 days. To celebrate their commitment to science, I thought we should try and build some straw rockets of our own. So to start off with, as usual, you need to gather your materials. It is quite useful to have a science notebook to write down your equipment, steps, and observations. As well as that, you will need a pen or a pencil, some origami paper, and a straw that's bendable. So to start off with, I need to fold the paper diagonally in half, making sure that whatever side I want to use is on the opposite side. So I need to turn my paper over to the lighter side, which has already been done. So I'm now going to fold it into the triangle, making sure that I meet the corners as neatly as possible. You ideally don't want any orange showing. So I now need to unfold it and repeat on the opposite side. So what we've ended up with, if I unfold it, is a square with an X. Now I need to fold the paper in half vertically so that I end up with a rectangle. And now I need to unfold it, turn it 90 degrees, and fold it again in half. So if I unfold it, now you can see we've got 1, 2, 3, 4 squares and the X still in the middle. So the next step is to fold it using the folds as a guideline to form a triangle. This bit can take a lot of practice and patience if you're not used to origami. It can also fold into a diamond shape, which is not what we're looking for on this occasion. Again, you need to make sure that your papers are as neat as possible and use the X folds as a guideline. Okay, there we have it. So you can see that we've got 2 triangles attached together, but we just need it flat on this occasion. So the next step, now that we've got our triangle, is to fold the sides of the first triangle down towards the middle, so you're still leaving one triangle at the back. And what you should end up with is a diamond shape with a triangle in the background. The next step is to fold the sides of that diamond into the middle. So you should have smaller diamond shape within the triangle, like this. And now I need to fold the feet, so these two bits, outwards. These are the landing pads. They provide stability to our rocket so it could stand up. And now what I'm going to do is I'm going to turn it over and repeat steps 5 to 7. So I'm folding the triangles into the middle so that I end up with the diamond. And the sides of the diamond. So you end up with something like that. And then I need to fold out the feet. And if I've done it correctly, I should be able to open it up and stand my rocket like so. The next step is to get my straw, and I might want to turn the rocket round a bit to the side so I can access the middle. And put the shorter end into the straw, and then with the longer end blow into it. It might take some practice. You might want to vary with the strength of your puffs. Okay, so as we saw, that went straight off the table. We want to try and get it upwards. So what I'm going to do is I'm going to take it off the table slightly and hold it, and then withdraw my hand when I blow. So it went slightly upwards. So this explains by Isaac Newton's laws of motion. Isaac Newton, as you may know, was a scientist who discovered gravity, and that was found from an apple from his apple tree falling upon his head. Gravity is a force that brings us down. So if we are to apply his laws of motion to this experiment, we see that laws 1 and 3 are applied. So law 1 is when an object at rest remains at rest, and an object in motion remains in motion at constant speed and in a straight line unless acted upon by an unbalanced force. Law 3 is whenever one object exerts a force on another object, the second object exerts an equal and opposite force on the first. So, in law 1, what we can see is that the rocket stays still until I apply a force. So I am blowing into the rocket through the straw, and thus the rocket stays in flight until gravity causes it to come back down. So I'm causing the rocket to move, the first object to move, by blowing air and causing a thrust, an upward force. However, as we also saw, the rocket also moved off the table, just in a straight line. So I am the second force which is causing an unbalance in forces. But then, as we also saw in both cases, the rocket either dropped back onto the table or it fell onto the ground, and that is gravity in action. The third law is the action of blowing through the straw creates the reaction of the rocket moving. So it's similar to the first. Again, the rocket is the first object and I am the second, and I needed to exert an equal and opposite force on the first. So that's why I was saying I needed to vary the strengths of my puffs to see if that would make a difference. Because again, it depends on the weight of the rocket. Scientists may have to vary how many engines a rocket may have, and that would ultimately require more fuel, requiring more energy or force to go upwards. So that is the end of this experiment. If you've enjoyed it, please give it a like. I would also like to point you towards Dr. Dot's online science club. It's very good. I'm a member. It is currently £20 a month, which is pretty reasonable. And there's lots of fun activities to get involved with. There's an online chat there, and she also hosts monthly Zoom sessions. Last time we had a pub quiz. So if that's something that you're interested in, then please sign up. It's for parents and children alike, but it's also for adults who show an interest in science but never really managed to develop that as a career, or there's even some professional scientists on board. It's open to anyone really. So give it a go and see what you think. Thank you. Bye.